Hi all, welcome to Public Cloud Design Tips and Tricks. Today's topic is caching design strategy. The problem statement is how to design a best caching strategy in public cloud applications with the offerings from Azure Redis case, from AWS Amazon Elastic case, from Google Cloud, Cloud Memory Store. Now, what are the paradigms of caching? Caching is a design pattern to improve the performance and scalability of an application. Why cache? To improve the query response time or latency by keeping frequently used static data in a temporary storage. When to cache? When application starts or based on first request. Where to cache? It is based on your design. It can be in memory or distributed. What should be cache frequency? Can be periodic or can be based on event. Now there are few patterns for caching actually. So let's discuss one by one. So caching pattern depends on how the application reads or writes data. So the first pattern is case aside. This is good for read heavy workload. How it works is there are always 340 involved in this kind of a pattern. One is the consuming application, the other one is the application case itself, and third one is the database, the final repository of the information. So how it works here, the application first try to read information from the application case which is isolated, and if that information is not available in the application case, then it goes to the database directly to read that information, and once it gets the information it writes into application case. So that is how it works, and it is always based on a lazy loading approach because it is always triggered with an incoming request. The second one is read through case. So the primary purpose of read through case is it's always the case is always sync with the database. So what happens is here the consuming application first read the data or the information from application case, and if it doesn't get that information, likewise in the first use case, in the first pattern, it try to read data from the database, but the basic difference here is the application case itself reads the data from the database. So that is the difference. And again, it is best suit for read heavy workloads. And the data model that resides in application case is always an exact replica of the target database. So that is how it works. Now coming to write through case, it is good for write operation workload. And again, the purpose is same. Cases always try to sync with the database. So how it works? Same like the second pattern, the consuming application try to write data into the application case, and once that is written in the application case itself write the same data or the information into the database. So what is the effect? It always add latency as there are two writes operations are being performed. It always work good with a read through case. So it is always good in combination with pattern 2. Coming to write back, so write back uh, in the write back pattern basically. So how it works is the consuming application try to write data into application case. So once the data reach into the case, it get acknowledges to the consuming application, and what once that acknowledgement happen, then it is returned to the application case, as well as in the final step the application case writes data into the database. So that is how it works. So get acknowledges once written in case. After acknowledgement, it gets written to the database, and it is also good for writing heavy workloads. So based on your design criteria, you can choose which pattern suits for you actually. Now let's discuss something on the typical microservice distributed architecture where different service actually operates in uh, different heterogeneous systems. Service 1 talks to DB1, service 2 talks to DB2, service 3 talks to DB3, and there is a aggregator service used by the consumer, and that is responsible to fetch information from service 1, 2, 3. So that is how a typical microservice and distributed architecture looks like. Now in microservice scenario, we have two kind of case design strategy. One is in memory, other one is shared casing. So what happens in memory is there are different instances of service running actually, and they are connecting to the same database. They are fetching the information to store in a temporary storage, and in this case, the temporary storage is an in-memory storage. So in-memory storage always work within the same system or within the same process. But the important thing here is the case of that particular instance is always a time-based snapshot. So, for example, here there are two instances of service one is running, instance one and instance two. They have their own in-memory case, and both the in-memory case are based on a time snapshot basically. So T1 and T2. So there can be cases where you have some delta informations between T1 and T2. So eventually when the consumer starts, talking to case 1 and case 2, it may end up with a data change basically. So that is how it works. And again, it is memory dependent and not good for non-static data. Means if you're doing some write operations or your database is having write operations, then you may get different data for different instance. Still it is faster because it always operates within the context or within the same systems. And as I explained you, each instance of the service have different independent case. Coming to the uh, shared casing is always kind of a single source of truth where you have the case applications running separately in a separate systems, and each instances of the service will talk to that single case applications. The benefit of shared casing is you can scale it to a different level because it is an independent application. It can scale into clusters and nodes, and then it can cater different or multiple requests basically, high workload as well. And now it has always a single source of truth, and as compared to in memory it is slower because it is always having a different machine where the case is running, and because of that you have one more hop you are traveling basically, so that adds the delta part for the response. And because of that separate machine where the cache is running, you also add up with more maintenance. So that is how it looks like shared caching. Now the data security consideration in case designing is fundamentally secure the data at rest, secure the data at transit. Then once you secure the data, then who will access that data? That is more authentication operation. So who can access the case, and which operations can be allowed to use that case in terms of read and write. Now coming to more granular approach, actually data can be split into partitions and access can be granted to that required partitions only. Similarly, those partitions can be encrypted with an encryption key, and those keys can be shared to different consumers. So that is how, on a high level or on a theoretical level, you can secure the case informations. If you want to deep dive more into caching strategy, caching design, then there are different links you can follow, and based on your design requirement you can start practicing adopting caching design strategy. That's it for the day. Thank you and have a good day.